excess undigested protein.
This is partly true when you take all calciums under consideration, but it would not be true of any one calcium. I mean, thinking of calciums, think of all calciums, many hundreds of calciums, thousands of calciums. Think in that kind of a term. So long as you're thinking in the category of 4 or 5, it's kind of difficult. But the liver manufactures over 6 billion different enzymes, and each group of enzymes contain a different form of calcium. So when I say there's 250,000 different kinds, I mean in foods we eat. I'm not talking about the possibility of how many different molecular structure kinds of calciums there are. There's many, many kinds of calcium. So try to have a great variety in your food, and in a great variety of foods there is safety. Calcium, the lack of calcium, is the greatest cause of nervousness that there is. Neurosis, undigested foods, lack of calcium, a cause of ulcers. So whenever you begin to study the effect of calciums upon the body, you are studying the most important element that is in our diets at all. The very fact that calciums are so essential to our foods, so very essential, then it behooves us to pay much attention to the calciums in our diet. Food taken from farms with only 50 pounds of water-soluble calcium per acre is deficient in what? What's it deficient in? Calcium. Deficient in calcium in some form. Is the calcium in peanuts the same kind as that's in calcium? I mean, in the corn? What's that?
But not like that.
Not like that. What form of calcium will you find in peanuts generally? What form of calciums do you generally find in peanuts? Oxide, that is correct. Things that go under the ground generally have calcium oxides. Things that go above the ground generally have some other form of calcium. What is the type of calcium found in corn? What is the one greatest by measure and volume? No, not a lactate. No, it's not phosphate, but it's not the greatest one. It's a gluconate in fresh corn, a calcium gluconate, but as the corn gets a little older, it turns to a lactate form of calcium. But when the corn is dry, then it's back into what form in dry corn and grits? What form of calcium is it in? It's in the oxide form then. It's in oxide form. So as you begin to work with these calciums, they become very, very interesting to you. They really keep your eyes open, keep you working. Now, what kind of calcium would you find in good carrot juice? A little oxide, but that's not the greatest kind. What is the greatest kind you would find in it? Almost got it. I'm speaking about fresh corn now. Carrots, okay. Carrots, fresh carrots. I'm talking about the fresh carrot. What's that? Phosphate? A little bit of phosphate, but that's not the primary one. A little gluconate, but it's not the primary one. Carbonate. Why? Why would carrots be richer in a carbonate? The sugar and the carbon in the sugar makes it so. Who will tell me what the formula for sugar is, ordinary white sugar? Well, we've got a number of different answers, and all of them are correct. This is the most common one from cane sugar, from sugar cane sugar. This is the one most common. C6H22012 is the most common one found in ordinary cane sugar. That's a variable. It varies a little. Now, what's that? It could be 11 or 12. It is 11. Okay, it was 12 when I went to school. Okay, it could be either one, or even a 10. Now, notice in this sugar, we have carbon. Carbon. What is the atomic number of carbon? What's that? 12. How many have memorized the atomic table? Atomic number table? All right, it's 1 and 12. 1 with a 12. Now, what, assuming that of your averages, of your average number, on your average numbers, I gave you 250 for your anions and 750 for your cations. What is the atomic number here for carbons? What you got? 9,250? Would be the amount of Millhouse units in 1 mole of carbon. And that, oh no, on the, what's that?
Sir, where did you get the +2 on the outside from?
That's 12.
Okay, all right, now, thank you.
That's a 12. Okay. Anybody, is anyone that doesn't see this? Yes.
Where does the 750 come from?
It's the average. It's the average value of a cation. Oh, it's a hydrogen now. What is this? 150, this is your hydrogen, 1 and 1. It was 750 plus 1, but that's not the way it is. It's 750 plus 250. Thought maybe somebody would correct me on that. Maybe you're getting sleepy. Okay? I was waiting for somebody to correct me on that. 750 plus 250 is 1,000. Now on the oxygen, times 750. But now, that's your first step. Now your second step is to multiply it by your 6, by your 22, and by your 11. We got 22,000. And here you have 135,750.
134,750.
Okay, thank you for helping me. Now, there is your total potential energy in 1 mole of sugar, carbohydrate. Now, how do you suppose that nature here joins carbon from the air and puts it into water to make sugar? How do you suppose it does that? What would be the agent that nature uses to make that union?
Energy from the
Yes, energy from the sun is a factor, but what is the element? What is the element that is the catalyst here?
Nitrate. Nitrogen.
No, it isn't.
Calcium. Electrolyte.
No.
Could you state the question again?
What? This is joined together through the process of photosynthesis. That is where the heat comes from that makes the union. But now what is the element that joins these three together? What is the catalyst?
Water.
No, it isn't. No. No. It's phosphate. It is phosphate. Phosphate is the element, is the catalyst in this that actually causes the water molecule to expand large enough to receive the carbon.
Phosphate is not an element.
Phosphorus is, but phosphate is in the phosphate form. We think of phosphorus.
So if you're saying an element, then you're saying phosphorus.
That's right, but I'm thinking of phosphorus in phosphate form. The element would be phosphorus, but the form would be phosphate itself. Why? Why would it be a phosphate here? What's the difference in a phosphorus and a phosphate? What is the formula for phosphate?
PO4.
What?
PO4.
P2O5. P2O5 is correct. Or 4, either one. It can be P2O4 or 5, either one. So it's a phosphate form. Actually, it's the phosphorus that does the joining, but in order to get it into the tree without burning, what would happen if you expose phosphorus to the air? Combustion starts, yes.
P2O5 phosphorus pentoxide.
No.
I thought PO4 was phosphate.
Either one is a phosphate. Either one could be a phosphate. P2O5 or P2O4, either one is a phosphate. You can get technical if you want to by changing it, but it's not that important. Okay, it's phosphate that causes that molecule of water to grab a hold of carbon, and as it grabs a hold of this carbon, then the evening begins to get cooler, and it closes down, and the phosphate squirts out, so to speak, leaving the union of C6H2211. The heat of the sun, and this is the way you make sugar. Now, notice how sugar is made, and then it gets into our system. And without phosphates, again, it can't come apart. In our systems, it should come apart again to a certain extent. And as it begins to form into our systems in soluble form, in the form of a soluble like the sugar put into your coffee or tea or whatever you're putting it in, becomes in soluble form in molecular structure, just the same. Then, in this formula, it is a cationic substance. And a cationic substance strikes the anionic substance of the bile, then it gives off what? Energy, but then what's the name of that energy? Glucose. Gives off glucose. In other words, there you've got your formula changed again. Glucose and sucrose and so forth. And it is these variable parts of sucrose, glucose, and so forth that our body needs in order to manufacture what substance to control our body temperature? Alcohol, that's right. And also what substance to control our body weight? What's the name of that one? Thyroxine, that's right. But what is the name of the one the liver man uses to What's that? Glycogen. That's right, glycogen. And then there's a number of others, but this is the way nature puts together and takes apart things that become a part of our frequency. The reason I put this on the board is to show you how frequency fits into the pattern of dietary purposes. Do you see this now? Is it clear to you? You do not see it. Some of you beginning to see it. I see some of you beginning to see through. I wish I knew how to make it plainer to you. What does carbon do to your system? Carbon is the governor for moisture in our systems. I said that this morning. Have you forgotten it? Carbon is a governor for moisture in soil and plants and people or animals. It is the governor. Did you ever see any inorganic meat? Did you ever? Yes. Did you ever see any inorganic honey? I saw some advertising in the health food store organic honey. Yes. So, I asked the person in the health food store to get me some inorganic honey. So, these are factors you need to keep in mind. Do you see now behind this the amount of potential energy that's in 1 mile of carbohydrate? In the fourth course, then we take these numbers that are so big now, and we make little numbers out of them in order to handle them. But at that time, we will not be using or dealing with geometrical chemistry or math. We'll be using somewhat of a relative math. Now, what is the difference between a geometrical math and a relative math? Mathematics. What's the difference? In geometrical math, you're dealing with angles and squares and parallel lines. But in relative math, you're dealing with cycles, complete cycles. If anything goes far enough, it will come back to its point of origin. And not only that, in geometrical math, parallel lines never meet, but in relative math they do meet. And they come back, and not only cross once, but they cross twice. So these are factors that need to keep in mind to understand how marvelous we're made.
In your program, Dr. Eames, you have trouble zones and patterns in the central nervous system for this time. Have you covered that in your treatment of calcium, or is there more to that?
What I have here, it's yes, and patterns, central nervous system. We're still on this, and the calcium is the greatest cause of nervousness and neurosis that there is, and the lack of calciums upset our balance. What is necessary for calciums to become available besides vitamin D? Selenium, but there's one other product. Water, but there's another element that I was thinking of. Carbon. Carbons are necessary for the calciums to become available. In what form does calciums become most available to our system? In two forms. What are those two forms? No, needed by the greatest volume. No. No, that's the one it doesn't use. I know, but after you put it in lime water, it's not calcium hydroxide any longer. If you have a calcium oxide water, liquid calcium then. That's right. Calcium phosphate is one. And what's the other one? Calcium phosphate is one? Carbonate. That's right. We take it in by carbonate form, and then what does nature do to it? Nature makes an oxide or phosphate out of it. This is the way nature uses it. In our muscles, it's largely carbonate, but in our bones, phosphate or an oxide form. So this is the way nature changes things around and uses these particles of energy for our growth and our strength and the building of our bodies. What is the greatest enemy calcium's ever had? Alcohol. Alcohol. And lots of times you will find people that their own body manufactures too much alcohol. Alcohol does two serious damages to people's system. What are they? The first one is what? Destroys the liver by destroying the calcium. And what's the next effect that it has?
Brain cells?
Well, that's rather different. The pancreas is involved, but it does something else before that. What else? There's one more thing that it does. Yes, kidney stones, but there's something else more important than that. Stops digestion of food. That is what I wanted you to say. Slows down digestion. It preserves the food in your stomach, and therefore you become minerally deficient, minerally starved, and it's one of the great curses in our country today. It is said that in America alone we have 18,000 medical doctors who are alcoholics. Think of it, 18,000 alcoholics, medical doctors. 18,000, my, isn't that terrible? Yes. Yes, there's a difference. Depends on how much you drink. Now, the central nervous system, we have two nervous systems. We have two systems of nerves. Who will name? What is the name of one, and what is the name of the other? Vagus nerve is one, and what's the other one? The cranial nervous system. What is the difference in the cranial nervous system and the vagus nervous system? Right, vagus is the central organs that controls the vital organs, and the other one is the one that goes through the spinal column and controls the muscles and activity of our system. So these are the two different types of central nervous system, and the vagus nerves are also called the central nervous system. Now, if you have a calcium deficiency, which set of nerves are going to be affected first? The vagus nerves are going to be affected first. That is true, the vagus nervous system. Why? That's right. All diseases start with the vagus nerve, but why? Yes, but there's a reason why do all diseases start with the vagus nervous system. Because the liver can't get the messages, but because there's another reason still. Because of a mineral deficiency, which is necessary to supply all other organs. Because of a mineral deficiency. The mineral deficiency then affects the nervous system, the vagus nervous system, so that it cannot carry the messages. And one stone upon another. And it bears down and down and down. Cause and effect. We're talking about cause and effect. This whole course is about cause and effect. Nothing more than cause and effect. Yes?
Does the central nervous system get its energy through the blood, or does it get it directly from the organs that it serves?
Well, it's the blood that carries the energy to it, yes, to a point. But a lot of it carries it straight by ionization, like in an ionization tank. It does not all have to go through the blood. It does not all have to go through the nerve sinew itself. Sometimes it's the loose ion It's on a runaway course that gets trapped and caught. Yes.
Did you make a statement that the vagus nerve is not part of the cranial system?
It's not part of the cranial nervous system. It's a different system altogether. It's a part of it, but not a part of the cranial nervous system. The cranial nerves go through the spinal column, and the other one doesn't. That's the way I was taught it years and years ago, and it's the only one that makes any sense.
That's true, but your semantics are not contiguous. See, the vagus is cranial 10, and you're right that it comes through, but it's part of the cranial nervous system.
That isn't the way I was taught it. There were two complete systems, complete two different systems. The vagus nerve originates in the left quadrant.
So that's true, you're getting in your sympathetics and your parasympathetics, but you're saying it another way. I mean, I was taught differently. Maybe everybody else was taught the way you were, but not the way I was taught.
Yes. Well, were you taught that the roots of this vagus nerve was in the left quadrant of the brain?
The brain, yeah. Origin in the brain, and it comes through.
That's right. But the others does not originate in that department? The vagus nerve, I mean, the cranial nerves come out of the other 3/4 of the brain?
Well, I'll give you an anatomy book down the road.
Okay, good. I'll be glad to. But anyway, people who have damage on the left quadrant of their brain toward the back generally do not survive as well as the others having damage in the other parts of their brain. There's much to be known about the brain yet. Also, the lack of calcium causes nervousness, and the lack of calcium and nervousness together causes ulcers. And that's the first red light sign that you're deficient in calcium, is ulcers. The calcium in cabbage juice is the easiest form of getting calcium accepted back to the system to get the ulcers well, but the calcium must be squeezed fresh. The calcium also in sauerkraut is excellent, providing your body is alkaline. So these are forms of calcium that you need to take into very, very close consideration whenever you begin to study about calciums. Also, try to remember that I'm trying to put into your minds a 4-year postgraduate course in biochemistry in about 31 days. And there's a lot of things we're going to have to take hook, line, and sinker.
In the standard medical books, they mention for absorption of calcium, they recommend the acid stomach. And I would like you to make a comment about the alkaline calciums and the acid calciums and how they are absorbed in the stomach.
In the truest sense, there's not any such thing as an acid calcium. Even though we have gypsum and calcium lactate in the test tube, they appear to be acid. But in our system, calcium is calcium, and if there are more cations surrounding the calcium, then it gives the appearance of being an acid, like a gypsum or lactate. But calcium is still calcium. It doesn't change the direction of the molecule's electron. And what happens is nature peels off the cationic substances, and then you have the alkaline substances, which is a form of calciums that are available to your system. It is time for a break.
Please fast forward to the end of this side. Then you'll be ready to turn over at the beginning of Dr. Ream's talk on cause and effect theory of ionization.